The last time I went.
She said, yeah, I did.
Yeah. I don't care what's coming from PCA, so. I'll give you my hiker. I'll play your own. I know, I'm just weird.
You were already tardy. Okay, good. Yeah, absence too.
Like remembering the fact that Shelby had a...
Alright, we've talked in here a little bit about the log button. The log button on the far left-hand side of your calculator by the 7, I think it is. Yeah, that is an understood log base 10. Okay, anytime you, like we've done stuff like this that had like log base 2 of 3, that base is 2. Anytime it doesn't have a base, if it just said log of 3, that's an understood base 10. Okay, so anytime they leave a base out, it's an understood base 10. And that's just the plain old log button over there on the left side of your calculator. So log 3 is the same as log base 10 of 3. Anytime it leaves the base out, it's an understood 10. That's weird in math because usually when they don't write something, it's an understood 1. This time, no base is an understood base 10. Okay, so you've actually got options. If you were told, just this problem that I wrote here, if you were told to evaluate the log of 3, you could hit math. Scroll it down until you find log base and fill in log base 10 of 3. Or you can just push the log button over there on the left side. Okay, so you could do that either way on that. So that's what we're going to do first. I'm going to give you a few problems just to familiarize yourself here. We want to know what the log of 41,600 is, what the log of 43.5 is, and one more, what the log of 0.442 is. So that's a 442 that looks like Chinese down there. So grab a calculator, see if you can get those. Let's round them to tenths, hundredths, to the 10,000ths. 10,000ths, that's 4 decimal places. Let's round them to the 10,000ths. Yes, 43.5, yes. What's it, 8? So yes.
Hey, what is log sample?
Logarithm. That wasn't that smart, but answer. It just means you're finding the exponent. So what this actually means, this is an understood base 10. This means 10 to the what power is 41,600. That's what you're actually finding.
Oh.
41 is around to the 10th place.
10,000ths. Have you been here? I've said answered every one of your questions. Earth to Bailey. Hey, when Austin was playing Brain Dead just a second ago, he reminded us of some good stuff. Okay? What you're actually finding on this, remember it's like Bailey reminded us, it's understood base 10. So what you're actually finding, 10 to the what power gets you that number. That's what logs mean on that, Austin.
I'll make you sure that was Wattie's question.
Well, I said
What are you
playing.
talking about?
I said playing Brain Dead. Like you were just
That was
pretending.
his question, though. Why are you blaming it on me? You said, what's the log stand for? I knew what log stood for.
Alright, what you get on a log of 41,600? 4.6191. So if we did 10 to the 4.6191 power, that should get us close to 41,600. It's not going to be exact because we had to round, but it should get us in the ballpark. Katie's checking that out and we'll see how close it gets us. 10 to the 4.6191 power. Got 41,600.63, 64. So it was pretty close. 6,400's off. That's pretty good on that. Alright, so what'd you get on the log of 43.5? 6385. Now, since Austin reminded us a little bit on this, if you were concerned about your answer, remember this would be 10 to the what equals a fraction. So to get a fraction, this is the same tenths, hundredths, thousandths. This is the same as 442 over 1,000. So that's going to have to flip that, which is what Valentina knows why it's going to be expected to be a negative on that. So tell me what you got there. There you go.
There you go.
What's the matter?
I probably no, I don't think
It's not.
I got the same.
no, but I got 3 to 5. No. Why did you have which one? That would be it. Why do you have 3 3? I didn't do that. I got 3. Hang on. I think unless I'm going to time, you know. Oh yeah. Okay. Well, now I get it. Because right here on my last one there was a 0 after the 4. I don't know how. But now there's.
Okay, now gonna put that. Shall somebody down? Gonna put that log button with some different formulas that we have. This one we've got here. This is the formula for finding the pH value, and it's talking about finding the pH value of different swamps if they're acidic or a neutral or alkaline. The pH is negative log of 6.3 times 10 to the negative third. That's just the definition of pH. That's how pH levels are calculated. I do not know that. I had to be told that. For some reason, I don't know why, I don't have the definition of pH memorized. So, there you go. Alright, it says find the pH of water with a hydronium ion concentration of 1.2 times 10 to the negative third. Okay. So in this, I got to tell you this because this is written crazy. In this equation that I gave you, that's really not the blanket formula. That is the hydronium ion concentration. So I gotta find if there's a symbol for that. H base 30. Is that hydronium? You know, chemistry brains. Alright, so this would be the real formula here. I already plugged in a hydronium concentration for you. This H30, that's the hydronium concentration. So the wetland that we have, we'll go ahead and work it with this one, and then we'll do the new problem that I gave you in a second. Okay, so this just strictly becomes a calculator problem. You got to know how to plug stuff in. So I would just work left to right and do it just exactly like it says. Hit negative, and then hit your log button. No, this is just a normal log over there on the left. So negative log on the left by the 7. And then 6.3 times 10 to the negative third. Let's just do tenths this time. About 2.2. Everybody able to get that? Let me know if you need help pushing buttons, because this whole that's why we didn't do this lesson the day the calculators were going. This whole lesson turns into calculator stuff. There's a little table that I have here that tells you if the would be classified as a bog, a fen, a marsh, or a swamp. That's what you would use that for. 2.2 would be a bog. Guess if you live on Florida or Louisiana or something, that'd be good to know. Alright, let's move on and keep that same formula here, but we're going to work backwards. I want to give you the pH, and we're going to solve and figure out how much hydronium concentration it has. Okay, this has a pH of 6.5. And we want to figure out what that means its hydronium concentration is. Okay? So what we're looking at there first thing I'm going to want to do, and this is a little bit different than our normal solving equations, first thing I'm going to want to do is get rid of this negative over here. So I'm going to know that, and you can write it in either order, I'm going to know that the log times the hydronium is equal to negative 6.5, right? Everybody okay on that? Just multiply or divide by -1 and you get that? Okay, bless you. So now we're going back to what Austin and Blake were talking about a little bit ago. This is the same as log base 10. So this is 10. This is, y'all remember how to rewrite it into exponential form? To the -6.5 power is equal to our hydronium concentration. So all you're typing now is what is 10 to the -6.5 power. And it's going to be small. You might use scientific notation. I'm not sure. Okay. So tell me, my scientific notation, I don't want an E. It's times 10 where the E is. So tell me what you get to the nearest 10. Very good. So we would have, and that would be, if you wrote that out, that would be 0.60. 1, 2, 3, 4, 5, 6. So that, whatever that is, swamp, bog, whatever, doesn't have very much hydronium in it at all. It's almost no hydronium there. Alright, next formula that we got, we're going to be measuring some sound with some decibels. Okay, so the decibel level is equal to 10 times the log of the intensity, I, divided by the intensity base 0. Alright. Those are I's. I read it to you. Yes, this is a D.
I thought that was
I mean, I've read it all. Y'all gotta listen.
right.
Alright, it says the loudness, here's the background of this. I don't know where they come up with all this stuff. The loudness of sound is measured in a unit called a decibel, abbreviated dB. To measure this unit, we first assign an intensity of I base 0 to a very faint sound called the threshold sound. If a particular sound has the intensity of I, the decibel level of the louder sound is that formula there. Okay? So here's your problem. It says if music delivered through the earphones of an iPod has an intensity I of 3.162 times 10 to the, oh, I didn't say myself enough room. I equals 3.162 times 10 to the 11th times I base 0. Okay. Wants us to find the average decibel level. Okay, so all of this is going to go on the top where that I is. So our decibel level is going to be 10 times the log of all, there's our whole I, we've got to put that whole thing up there, 3.162 times 10 to the 11th times I base 0, all over I base 0. Now here's what you see, the good news is on those I base zeros, you can cancel those out. So now all you're dealing with there, we've got our decibel level would be equal to 10 log of time 3.162 times 10 to the 11th. And let's go to a whole number on this. 115. Y'all check and make sure Kelsey got it and make sure you can get it. There used to be some table or chart about what was considered like too loud and all that stuff. It says permanent hearing damage can be suffered at decibel levels of 150.
Oh, I go.
So that iPod there is 115. That must be a pretty loud iPod. If it 150 would make you lose your hearing. Some of y'all listen to it louder than that. It's annoying. Nobody wants to hear your earphones.
I do, Coach Rock. I'm dead.
Yeah.
I don't want to hear your earphones. That's probably why you're deaf. It's like the never-ending
No,
circle.
I'm dead since I was 3.
Listening to Sesame Street too loud.
No, I was a Bob the Builder.
Bob the Builder.
Yes,
Sweet can.
And Dragon Tail is here.
All right, now The title of the lesson that we had there was common logs and natural logs. That log, where it's just written log, which is an understood log base 10, when it's just written log, that's a common log. So anytime you see common log, it's just log base 10. Okay, then natural log is the other part of our lesson. Natural log is LN. That's the LN button. I don't know why it's not NL. That would make more sense to me, natural log. But anyway, natural log, if you wanted to do log base, it's log base E, the number E. And remember, E is approximately 2.718. It keeps going forever. It's like pi. It's irrational. It goes forever. But there's an LN button on your calculator. So you can just use the LN button. It's right underneath the log on the far left. Okay? So let's do some warm-ups with that like we did with the log button. Let's find the natural log of 0.01, the natural log of 27, and the natural log of 529. And let's round to the nearest hundredth on this one. Hundreds. Bless you. Alright, what was the natural log of 0.01? Okay, what's the natural log of 27?
3.295.
So that would go to 3.30 if we went to the 100 chip. And then the natural log of 529?
378. Oh, 271 actually.
There you go. There you go. Alright, now, what this means, remember these natural logs are log base E, so this would mean E to the negative 0.461 power is equal to 0.01. Well, remember, E is approximately 2.718, so 2.718 to the negative 0.461 would be close to 0.01. That's what you're actually finding on all that. Okay, okay, okay? Alright, let's do a couple problems with that. Natural log in a formulas. Everybody good? Alright. It says here, the altitude in meters that corresponds to the atmospheric pressure of X millibars is given by the logarithmic function f of X is equal to 51,600 minus 7,457 natural log X. Okay, the altitude in meters that corresponds to the atmospheric pressure of X millibars is given by that function. Let X equals, use the function to find the altitude when the atmospheric pressure is 400 millibars. So I told you that X stood for the atmospheric pressure, so I'm going to say 51,600 minus 7,457 times the natural log, and I said X is 400 millibars. Okay, let's round this to the nearest whole number. See what our atmospheric pressure is.
If I become a rocket scientist like this year,
Yes, it will. What are you getting, Bailey? No, yours is close. Yours is not. number, so looking at that stuff you got there, that would be 6,922. Is that what everybody got for that? Now this next thing, I'm going to show it to you, but I don't do this very often. Okay, you can decide how you want to do this. If you had, let me give you the rule. There's a change, it's called change of base rule. Change of base rule says that if I have, you'll be quiet, if I have the log base A of X, that's equal to log of X divided by log of A. Okay, so what this lets us do, it lets us take some base other than 10 and rewrite it with a base of 10. Okay, so if you had log base 5 of 12, and I did used to have to do this, okay? Y'all know that calculators are not my favorite thing in the world, and so I don't mess around and explore on them very much, and I used to not know that you could do log base in your calculator. So I used to always have to rewrite this as log of 12 divided by log of 5 and do it using that log button on the left. But then finally somebody told me, go drop, you can hit math and go down and there's log base in there. So I just quit doing this at that point. But it should get you the same answer. If you hit math and go to log base and fill in your 5 over 12, you should get about 1.54. If you do log of 12 divided by log of 5, it's the same. You should get about 1.54. So check both of those. See if it's not consistent, if you don't get about the same, and then you can do it either way you want. Now that a student finally taught me, I just hit math and do what y'all do, go down into the log base and fill the blanks in. But before I knew that, I had to rewrite it and use the log 10 button over there on the left. Kelsey checked it out and said she got it. Y'all check it out. Good. All right. We've got one more log lesson left that we're going to look at on Monday. And then Tuesday and Wednesday will be study guides, and we'll have tests Thursday.
That's a wrap for the day.
Everybody got it?
And then what are we doing? Because that's the Friday before spring break.
I don't know.
We're gonna watch a
Might
movie.
play a game.
We should watch. What's the clip from that movie you showed me every first day that I'm in here?
Spring break starts on the
Oh.
Really nice.